students, in first part or first video of gas laws, you have studied about the properties of gases, the standard variables affecting it, and now in this part we'll study the effect of temperature and pressure on the gas, volume of gas. Now there are some laws of gases or gas laws which are explaining the effect of these variables on the volume of gas. The first law is called Boyle's law. First law is called Boyle's law. Now students, in this part you know that as you have studied earlier, suppose there is a closed container or piston in which air is filled. Now if we close it on the lower end and exert pressure from the other end, means when we will increase pressure, the molecules of the gas will gradually come closer, means they will occupy less space, that is in a less space the molecules will be contained, that is the volume is decreased. At the same time, as a reverse, if we will decrease pressure, means if we will pull out the piston, in that case the molecules will expand, it will have greater space in which it will occupy, means when pressure will be decreased, the volume will increase, which is explained as Boyle's law. So Boyle's law explains pressure and volume relationship. Pressure and volume relationship. Now here we say that the volume of given mass of dry gas, given mass of dry gas is indirectly proportional, or we write inversely proportional, indirectly proportional to the pressure applied on it, at constant temperature means when the other physical variable, standard variable, temperature is kept constant, then the volume of the gas is inversely proportional to the pressure. Now you see, here the term given mass means mass should be constant, matter should be constant. Second, dry gas means even there will be no moisture or other impurities like this, so the gas should be dry. Now if you explain it mathematically, then how can it be done? Suppose let at P1 pressure the volume of gas is V1, then we write here that V1 is inversely proportional to P1, means if there will be less pressure, volume will be more, if pressure is increased, the volume will remain, will be V1. Now here we see that what is the conditions? Temperature is kept constant. From this part you see that if we remove sign of proportionality in any part, any topic, then we place a constant for it. Suppose here we place constant as K. So V1 equals to K by P1, and therefore P1 into V1 equals to K, which is constant. Now suppose in another condition, again when pressure is changed to P2, then volume changes to V2. Like suppose if pressure is increased, the volume will decrease, or if pressure is decreased, the volume will increase. So whatever may be the case, the next volume is V2. Therefore you write here V2 again inversely proportional to P2, and on the similar basis we see that P2 V2 is equals to K, again constant. So from this part you see that is P1 into V1 equals to P2 into V2 equals to K. So we can have this relationship. It means that the Boyle's law can also be defined as the product of volume and pressure at constant temperature remains constant. Means the product of, or we can write here, that is for, or we can write directly, the product of pressure and volume of given mass of dry gas. It must be written here, given mass of dry gas at constant temperature is always constant. Always constant. So we can define by this, or we can also define like this. This is Boyle's law. Now students, wherever there is some variation, then in that case we need to draw graph to show the variation of the different factors. So we can represent it in graphical method. Now students, the relationship can be shown by graphical representation. Graphical representation. Now in this part you see that is we have to study the relationship between V and P. So there are three relations, V versus P. Second, V versus 1 upon P. And third, P into V versus P. So we have to use these three relations. Now in this part, suppose students, suppose we take pressure and here we take volume. This is 0. Now suppose we take 4 units. 1, 2, 3, 4. Similarly 1, 2, 3, 4. 1, 2, 3, 4. Now suppose the initial value. When the pressure is 1, at that time suppose the volume is 4. Like this. This is the point. Now if the pressure is doubled, the volume will become half, yani half of 4, that is 2. So this time here is the point. If the pressure is tripled, the volume becomes 1/3, and 1/3 of 4, that is 1.33 approximately. So this part. And when the volume is made 4 times, the pressure is made 4 times, then the volume will become 1/4. That is at this part you see, here is the point. So this is the graph called hyperbolic graph. Sometimes when you need to directly draw the graph, then the value will not be given. So in that case, you just write here, students, you should draw hyperbola. But while drawing this, you must take care that this lower end should never be raised like this. That will be wrong. Next, sometimes a student draw like this. This is also wrong, because the graph should never be parallel to y-axis or x-axis. So this will be like this, down facing gradual curve. Now, so this is hyperbola for V versus P graph, because this was inversely proportional. In this part, 1 upon P, versus P. Now you have studied that V proportional to 1 by P. So if we take 1 upon P as a single quantity, let it be X, then we say V proportional to X. In that case, we will have a straight line graph, directly proportional, a straight line graph. It will not touch 0 because the volume will never be 0. So you must remember this part. Now come to the third graph. P and V, product of P and V with P. Now we have studied that the product of volume and pressure always remain constant. So whatever may be the value of P and product of P and V, it always remains constant. Like even if the pressure is changing, its value is not changing. Suppose whatever may be the value 1, 2, 3 and so on. So the graph will be parallel to x-axis. So these are the three types of graph representing the relationship between volume and pressure. Now students, we will solve some numerical problems. So the first example, that is example number 1. Example number 1. The example is, you can see here, it is written, a gas occupies 800 cubic centimeter under 760 mmHg pressure. Means this is the initial volume given and this was the pressure. Question is given that find under what pressure. Under what pressure means we have to find out the next pressure at which the gas will occupy 380 cubic centimeter. Means when you will solve the question, you will write this data. Like you see, the first volume is 800 cubic centimeter. And what is the pressure at that time? The pressure is 760 mm of Hg. But the next time the volume is changed to 380 cubic centimeter, then the question is asked that what is the pressure in this condition? What is the pressure? Now you see that according to Boyle's law, since the temperature is constant, so we have to use Boyle's law. According to Boyle's law, P1 V1 equals to P2 V2. Now you will put the data here and then you will solve the problem. So according to this one here, 760 into 800 is equals to P2 into 380. Therefore 760 into 800 by 380 is equals to P2. Hence this is twice, that is P2 is equals to 1600 mmHg. So in this way we have solved this problem. Now there will be another example. Students, the next example is again here. At constant temperature, the volume of a gas was found to be 400 cubic centimeter at a pressure of 760 mmHg. In this part you see that the initial values of volume and pressure are given. Now, if the pressure of the gas is increased by 25%, here student you remember, when it is given increased by, then the final value, that is P2, will be initial value plus 25% of that value. Whenever there is factor is given increased by or decreased by, then that value, that factor will be added to the initial value. But sometimes it is asked, the pressure is changed to 50%, 120%, 200%, then you will directly multiply the factor. So here it is given by. So if the pressure of the gas is increased by 25%, find the new volume. So again you will write its data like you see, that is the V1 volume is 400 cubic centimeter, P1 is 760 mm of Hg. We have to find out here V2, that is the new volume. Then what will be the value of P2? Since the pressure is increased by this factor, so 760 was the initial value. In this it has to be added, increased by, that is 25% of that initial value, this one. Hence it is 760 plus, you can solve it directly, that is 190. Hence it is 0, 9, 6, 15, 7, 1, 8 and 1, 9 mm Hg. Now this is the factor. Now you can solve. According to Boyle's law, P1 V1 equals to P2 V2. So in that case it is 400, it is 760 into 400 is equals to 950 into V2. Now solve it. 760 into 400 by 950 is equals to V2. Now this is 0, 19 4 ja, 19 5 ja. Now 580 times. Hence you see that V2 is 84 ja 320. Hence 320 cubic centimeter. What was the unit? Cubic centimeter. So this is the another example explaining the Boyle's law. Now students, you will be able to solve the problems if you go stepwise. You can also perform the calculation, or that is practice, by solving the examples given in the chapter and then go through the exercise at the end. Clear students? Now in the next part we will study another gas laws, that is called Charles law.